Hi, Mark. It's a pleasure to have you here.
Hi.
Great session, and you did a fabulous job moderating the panel. So, just wanted to get the summary of what you said on the stage. How mature is quantum computing?
Quantum computing is not very mature yet, but it has a tremendous amount of potential. It is very early in its evolution. There is venture capital that is investing in it. Governments are investing in it. But also what's unique is large companies are also investing in not only building the technology itself, but they're also partnering, and there also other big companies are already finding use cases for this technology, although it's early in its maturity.
The other thing that people are not yet sure about is quantum advantage. Can you talk a bit about that?
Yeah, thank you. So quantum advantage is a term, sort of a marketing term that's been used to sort of define where does quantum computing become useful to companies? Where do we get an effective return on investment? Because many end users would look at quantum computing as a black box, as a computer. They don't really care what technology's inside, but will it help my business? If I put X in, do I get Y out? Does it help me out? So quantum advantage is really about specific use cases, and some of them contemplated as material science and chemistry, as well as machine learning are some of the earlier ones. Even though there's already over 100 plus use cases identified, these are pretty exciting areas that are promising to have quantum advantage soon.
The other thing, Mark, is for the people who are not focus on technology in extreme sense, but they need to understand because they keep hearing, they heard about AI before that, the blockchain, but quantum is something that the ordinary folks do not get it properly. So is there a way they can explain to them what the impact is and what it does actually? Okay,
without getting too technical, so first of all, quantum is not talked about a lot, but we all know quantum from 100 years ago because of some, physics that was figured out, right? And that led to transistors, that led to lasers, that led to, a lot of this deep tech that we use today in our cell phones and et cetera, right? But the quantum that's being talked about today is really quantum 2.0, and it's really exploring all the other aspects of quantum. So what does that mean, right? So it turns out, again, not trying to get too technical here, but it turns out nature in and of itself operates in a quantum domain. It does things that way, and we solve problems with computers today, classic computers today, that are essentially not looking at the whole picture, right? We're using ones and zeros, right? Versus quantum computing is using much more, is doing things like nature does already naturally, right? So we're all going to be learning much more about quantum and quantum computing as time goes on, but it's very early, and it's going to build out probably over the next 5, 10, 15 years.
But what we need to understand is it has a lot of promise for a lot of us in the future. That's the good thing to keep in mind, I guess.
That's exactly right.
Mark, thank you so much. I appreciate the opportunity.
Thank you.
Right.